Hello students, today we're going to be doing Inquiry 8.1. We are going to be modeling convection in the mantle. Yesterday you should have done the initial reading and so forth about convection. And if you remember, convection is basically where heat rises and cool sinks. So if it's air, then the hot air will rise and the cool air will sink, and it's caused by uneven heating. Same thing with water. Warm water will rise, cool water will sink. And the same thing possibly happens in the earth, and we're going to look at that. In the mantle of the earth, we have convection, where we have heat rising, coolness sinking, and this causes convection currents. So for our question, how does convection occur in the mantle of the earth? Convection currents in the mantle of the earth are caused by blank. So for your hypothesis, think about what causes any kind of convection currents, like air or water, and we can apply that to how the convection currents take place in the mantle of the earth. Our materials are found on page 103, and our procedures are found on page 105 to 107. All right, for our data, we're going to be using in class the setup that you see here. We have a special type of fluid in the jar that reacts to heat, and so we are going to be using those particular jars, and we're going to use a tea candle to create our heat. And so I'm going to show you a couple of video clips so that you can see this demonstration actually taking place. And for your data, it says to draw arrows on the diagram to show the movement of the fluid in the jar. So when you are watching this demonstration of this, I want you to pay close attention to the fluid movement in the jar so that you can draw your arrows. And then it says to add labels to indicate where the fluid is warmer and cooler. And then you have some questions to answer. So let's watch our simulation or demonstration of this taking place. We're going to watch both a real-time video and also a time lapse. So let's hit play. Okay, if you watch closely, you'll be able to see movement inside here. She's lighting the candle now. Okay, and you can already see inside some of the movement of the material. You see kind of the white cloudiness moving around. The heated part that's heating up rises, and then the cooler parts sink down, the warmer parts rise up. And you can start to see that taking place there. All right, now we're going to watch that in a time-lapse version of it, so it's slower. Oh, actually, they speeded it up. I'm sorry. They speeded it up so you can see the movement really fast there. It's more obvious. Okay. So, on your particular drawing here, you're supposed to draw arrows to show the movement of the fluid and indicate where the fluid is warmer and where it is cooler. And what observations of the fluid did you make? You can base that on what you saw from the video clips. All right, for part B, we're going to be looking at this particular diagram. It says to compare your diagram with the drawing below and the illustrations shown in the CD-ROM, the theory of plate tectonics. Label your picture in part A to show how it is a model of the Earth's interior. For example, what part of your model represents the mantle? And we're talking about the jar. The jar is our model. The jar with the special liquid inside was our model. So when it says to Think about the model, what part of your model represents the mantle. Think about your jar and go up to the picture on part A and label the part that you think is the mantle. And then which part of your model represents the core? Remember, the core is hot, hint, hint. So what was giving off the heat? That would represent the core. So go up to the part A picture and label that core. And then what part of your model represents a trench or a spreading ridge? So think about that and label that on picture A. Now, we are not going to be watching the from the CD-ROM, the theory of plate tectonics, so don't worry about comparing that to an illustration there. On this illustration here, you see the core where the heat's coming from. This middle section is the mantle, and then of course this top section is the crust of the earth. And here you see that the heat rises and the cool air sinks, and that causes these convection cells. You can see here these convection cells. The heat rises, the cool air sinks. Heat rises, cool air sinks. Same thing here. Heat rises, cool air sinks. Heat rises, cool air sinks. And this can cause ridges or trenches to form, because when this mantle material gets warmer from all that movement, it can spread and cause a spreading ridge. And it can spread to the point that you end up having a fairly large trench in the earth. Okay. You have a few analysis questions. These are observations from the jar that we heated. So some things for you to think about. And then we have our vocabulary section. You can look these up in the glossary in the back of your science textbook, or you can also use the CAMI dictionary to be helpful. If you can't find the word in either of those places and you Google or something like that, please make sure that you choose a definition that applies to how the word is being used in connection with the earth and the interior of the earth. And then lastly, of course, write your conclusion to sum up your lab report and to explain what you found out about convection. If you have any questions, make sure you message me, or if something's not going correctly, make sure you message me and I'll be glad to help you. Thank you.